corona, so I couldn't travel or anything, so basically I just started working immediately. And I started working at VeriCon, and I've been there ever since. I work there as what we call a component structural engineer. I don't know if it's an actual term, but the English translation can also prefab elements. So precast concrete elements, such as, for example, sandwich elements. In the last few years, I do more specials, like, for example, in the image on the right, you see a radar tower, and the base is from concrete, and that's one of the structures that we. Oh.
Okay, hi everybody. I am Vera. I recently graduated in October, and I was a board member of Koers last year. I started working at VeriCon in 2022 as a working student, and I made calculations for precast foundation beams 2 times a week. And when I graduated, I moved teams. So right now I'm part of the design and consultancy team. And right now on the screen, there's one of the projects that I've been kind of working on. It's going to be a huge water hall where you can surf in Nijmegen. So it's been nice to do. But we will start with what we're here for, from design to reality. Oh no, wait. I will introduce VeriCon a bit. We do design and consultancy as well as prefab engineering. There are 2 locations. We both work in Veldhoven, and we also have an office in Druten, which is near Nijmegen. There's about 90 of us, and all of us are either structural engineers or are 3D engineers, so they make all our models. And everything is done in 3D. So we are going to talk about Zuiderkwartier in Arnhem. This is the entire plot. It's going to be a huge development near the hospital in Arnhem, and we are focusing mainly on the 2 blocks on the left, and then the one that's right now highlighted is the southern cluster of the whole development. And right now it's actually in, they're building it right now, and then for the northern part we are still in the sketch designs. This is how it's going to look. So it's a bit of a square where there's an inner yard and there's different layers for the buildings, different heights. There were actually quite some challenges with the designs, and one of them is that there were multiple architects involved throughout the entire project, but also within this quadrant, which makes setting things sometimes quite difficult, especially if you have 2 different architects. One is working on the floor plans and the other one is working on the facade design, meaning that if you say you cannot put your balcony there to the one that's working for the inside of the building, and then the one that's making the design is like, but I want to have it there. It's not working. So those were difficult, as well as there's a lot of changes within the layout. It's actually a bit, it changes up quite a lot. Usually what we like as structural engineers, we like to have clear lines that go from the roof to the foundation, just one straight line. The architects wanted to play a bit with the facade, so those are all challenges within the entire design. Then there are some first steps that we usually do when we get the designs from the architects, and one of them is deciding what type of load-bearing structure it's going to be. This was already decided on by the contractor, and they decided to do precast floors with load-bearing walls. So mainly our job was to figure out which load pads we were gonna keep. We usually start a bit up higher, see which main room dividers are there. Those are right now indicated in blue, and yeah, they're indicated in blue. And these are going to be the main load-bearing walls. But if we went one floor down, we suddenly see that there's no way these walls do not continue on the ground floor, meaning that you either have to create columns, large beams, and it depends what the architect wants. So we suggested if it's possible to add those walls back on the ground floor as well to create this direct load path. And together, when we have those walls, we start already by making estimations of how many piles are needed underneath those walls, so the contractor has a feeling of how expensive everything is going to be. Then, due to the size of the entire plot and everything is connected, expansion joints need to be added, meaning that the building is architecturally is joined together. However, structurally on a different level, there are 4 different components within the building. These were achieved by making double walls, so they do not influence the behavior of all these components, do not influence each other. And then one of the other things that we were looking at is, since it's an apartment complex, everybody wants some outside space. It's usually created with balconies. And there are 2 types of connections for balconies. One of them we call isocorf, so you basically cast it in the floor to connection, so it's a cantilever structure. And one of the other ways is creating connections with just steel columns and beams. And actually, in this case, both were going to be used. And then, besides doing all of those things, we also start by kind of dimensioning already with rules of thumb or just very basic standard calculations. We start dimensioning everything. And then, once that's all done and everything is approved, we will start by more detailed calculations. So, this is actually the whole overview of the load-bearing structure. So it's quite a lot. You see that mainly all floors span in the same direction. That's just easier because then all walls that are important will be still in the same line, as well as all load-bearing walls are actually dividing the apartments. So there's no load-bearing wall within your apartment. Then besides creating the overall design, what we do as a lead structural engineer, we create a structural criteria report, which is basically stating the consequence class, load factors, basic loads. We say all those things. And then after we've done that, we make an entire stability and weight calculation to see the amount of weight mainly for the foundation, and then to see if the building is stable. We also engineered the steel elements, so mainly the beams and the columns for the balconies. And sometimes if there's large openings within the space itself, sometimes steel beams are needed. Then this is an example of one of the blocks of the pile plan. We also make that ourselves, and let's see, based on the advice a geotechnical advisor gives, what depth the piles are gonna need to be. And then what we also do within those things is we get pieces from other parties, one of them being the plumbing for the entire building. And usually the plumbing goes through the foundation beams. We check for clashes. For example, you can see here, for the walls, we needed to use reinforcement that sticks out of the beam and goes into the wall. However, right now, one of the plumbing elements is going straight through it. So we just had to say, you need to either move it, and if that's not possible, we also need to see if we can move the reinforcements. And what we also do is we, sometimes depends on the project, we also go on site to check everything. I recently went quite sometimes to check the reinforcement of the foundation. So you get to see the picture on the right mainly. They made also, there's quite sometimes some mistakes they made. For this, they forgot to cast, before casting the bottom part, they forgot the extra reinforcement needed for the walls. So we had to figure out ways to still put it in. And then last time I went, they had the ground floor laying with hollow core slabs. And that's the picture on the left. So it's also really nice to see what you've been calculating on, how that actually works out. So now I'm going to give Christine the word back. She's going to talk about the precast elements and more BIM stuff.
Yes, so Vera has talked mainly about the more main structure and architecturally, but from these structures and architectural drawings, we need to make designs. So in this image you see a 3D model, the architectural 3D model of one of the blocks. This is specifically block E. This model contains all kinds of information, from the type of brickwork, including every tiny electrical outlet in the building. And from this model, we need to go to products, because in this specific case, there's lots of prefab elements. VeriCon itself also specializes in prefab systems, one of our specializations. And to get to a final product, which is made in a factory, we need to go through a whole process. The benefits of these prefab elements is, of course, you have more control and it's efficient. So how do we get from these BIM models to the prefab structure? So when you see this architectural model, you end up eventually, in this case, with this model of the precast elements. So this structurally, at least, not architecturally, we're looking at it structurally right now. The whole structure is divided into all the separate floor elements, wall elements, cores. So if you look at the bottom, there's brickwork right now, but it's a massive slab. I think it's around, I don't know, 20 meters. The size is around 20 meters. Well, I think you can all imagine if this wall needs to be made into elements, it cannot be one big wall. So, for example, that's one of the parts that needs to be taken into account. An element needs to be transportable on a truck, because if it doesn't fit, you're not going to get it anywhere. And it's all these kind of things that need to be taken into account when you are designing these elements. So in the end, this is the end product that we deliver to the factories that produce the elements. Globally, when you look at it, the elements look quite, I don't want to say simple, but simple, like straight lines. However, once you start zooming in into what's happening on detail level, you'll see it's more complex than just these walls that go up. So, for example, this is the BIM model of all the building surfaces in this building. Next to that, you also have a model for in this case, the brickwork, and also a model for all the electrical installations. Next to these models, there's even more models, but yeah, I won't show you all of them. And all of these models need to be integrated into a whole. And you'll get a lot of intersections, and sometimes they clash. Vera already gave one example. So there's different problems you'll run into. For example, space limitations, and all different parties will have to discuss how they are going to solve this problem. So, for example, this is zoomed in a little bit more. You'll see ventilation systems, but also, you know, the plumbing for a toilet. And in the walls, you'll see these electrical outlets. These already have to be modeled because a factory needs to take into account where the holes will be, and our 3D engineers will model all of these outlets as tiny as they be inside the model, and there's not a lot of tolerance. So 2 centimeters is already quite a lot in a prefab, but it's all very detailed, and there's not a lot of room for error. So, for example, another clash that we ran into in this project, what you see is you see two floor slabs coming together, and underneath this section there's a load-bearing wall. The wall was not thick enough for both of the slabs to just be put on top of this wall, so that's why there's this shape which allows both floors to actually be put on top of the wall. However, in the same location, there was also a lot of ventilation channels, as you can see on the image on the right. So we call them, asking like, hey, what's possible? Can you maybe move them a little? They might say, yes, we can. But then you'll also have an architect that says, but no, we can't, because then it will become maybe visible. And this process takes quite some time. Everyone has their own problems, and together you need to get to a solution. In this case, I think we were able to move the holes, which are the blue holes you see in the floor, or at least away from this part of the support, because that was a critical structural element. And through this whole process, these are all the kind of problems you run into. So the solutions is in the detailing. Getting from a design to an actual building that can be made, and it's smaller elements. There's a lot of iteration. It takes a lot of time. You need to discuss with people. Need to be able to understand each other, of course, together come to a solution. So yeah, collaboration is key, and it's a long and iterative process, but in the end you'll get a building that can be made and where hopefully all parties are happy with the solution. So I think that's it. I don't think Vera has anything to add, so if anyone has questions, feel free to ask them. And I'm here.
All right, I do see a question in the back.
It's quite difficult to hear you, but I think you were saying something about how to communicate with different companies about the location. I'm not entirely sure what architect knows, but I do know many of them make like a first sketch. There'll be rough outlines, but these rough outlines will get more detailed because you can never know where exactly stuff will be, and when designing and you go further, every party will run into smaller problems. So like I said, it's an iterative process because you never know exactly where something will end up. And that's why these models are for, because we literally get this model from the architect or the plumber, and then you see where everything is, and then you're like, wait, is this what they had imagined? But that's not possible. And then you start discussing, and that's how the design goes and how you eventually get to the end result.
We usually, in the structural criteria report that we state in the beginning, we usually already give some boundary conditions. So for example, for this project, I know we stated that we assume that all main plumbing are gonna go through shafts within the building. And then they're usually already also indicated by the architect, because the architect has a very hard opinion on what should be where in his or her floor plan. So we try to figure out if those are possible, but I don't know with these floors, there are some more boundary conditions maybe. There are special pre-stressed floors. But usually we state that everything has to go through one hole in the floor.
Yeah, I think also part of your question is was how much of the plumbing a person actually makes themselves or not. Yeah, I have to say, for specifically the building services, I don't know, because we don't do that. But yeah, like she said, there's mainly boundary conditions, but they will probably have to look at detail and for basically every meter of wire where it goes, because they are very detailed models and everything needs to be there. So, any more questions? Yes? All right.
No, we only do the structural calculations. So mainly how the building will behave. We do some type of parametric designing within the company, but nothing with sensors or no, we don't. Any more questions? Precast structures, I think, have its pros and cons. You can build really fast, and it's more modular of a concept. However, if you have an architect or even a lead structural engineer that is not put his mind towards that type of system, it's gonna take a lot of time before to be able to actually create it. So if everybody puts his mind to it, it can really work. And you can also then reuse elements. Any more?
All right, if there then are no further questions, I would like to thank you for giving us the presentation. And I would like to thank you all for being here. If you do come up with any questions, you can always come downstairs to ask them, or probably send an email or something, or text, whatever. And you can always ask them later on if you prefer.